हाय हेलो एवरीवन मेरा प्यारा बच्चा लोग कैसे हैं सब हाउ आर यू ऑल डूइंग जल्दी फटाफट बता दे आई थिंक वी आर सीइंग आफ्टर वेरी लॉन्ग टाइम है ना इट्स ऑलमोस्ट 3 days सैटरडे संडे एंड मंडे एंड वी आर सीइंग आफ्टर 3 days so I know that you'll be having so much to tell okay everyone in the chat box tell me how you are doing and how everything is going in your life okay in the meanwhile do you know what I'm going to do I'm going to tell what we're going to do in this particular session मेरा बच्चा लोग tell me. This is a new session. This is an amazing session where we are going to start a new chapter which is oscillation with the first lecture and let me tell you beforehand it's a bit difficult chapter compared to all the remaining chapters. Don't worry. Here we are to make the chapter very awesome and very simple, right? I hope you all are ready for that. So let's get started and obviously before we get started I really want to know how you all are doing. So we'll start the session with a hi from every one of you. Hi Sumit, good evening. Amin, hello Ameer Basith. Nancy, hi. How's your weekend? मेरा weekend तो बहुत बढ़िया था. It was good. Pradeep, Lisha, then Garveet. वाह वाह, good good. Then Najia, Amin, Nancy, Lucifer, Lisha. बता दें आप सब लोग कैसे? Good morning, Nancy. अरे वाह. Why don't you open your windows and just look outside and see what is the climate and what's the time, what is happening around or outside? Samiksha, Lisha. Yeah, I'll do look into it, Pardeep. ठीक है? Thank you so much. Good evening, and by the way, Ajaz, Lucifer, so सब बढ़िया है ना? I hope everything is going well, and I hope everything is going awesome. And if you are seeing me for the very first time, बच्चा लोग, this is Ameer, yeah, physics educator at Unacademy. And a bit of introduction about myself. I hope you all can see it on the screen. है ना? I have an experience of more than 3.5 years in the field of teaching JEE, NEET and board student. I'm a BTech graduate from an IT Calicut in mechanical engineering, and this is all about me for the time being. Okay, more about me you'll come to know as we keep on proceeding with the session. Now, if you don't want to miss any of the updates from our YouTube channel, you can be a part of the Telegram channel where all updates are given. Link is given in the chat box, okay, and in the description box. Fine. Bugs Bounty, what it is, mera chalu? It's an amazing way where you can grab lot much of prices. Do you know what you'll have to do? You just have to 1 minute, okay? I forgot to plug in my. I hope it will be detected. 1 minute de de. Okay, yes, my pen is absolutely working. Thank you so much for waiting. Okay, what is Bugs Bounty program? It's an amazing program which can help you to grab lot much of prices. Do you know what you have to do? You just have to go to the description box. There you'll find a link. Fill the form if you are finding any inappropriate content in the videos uploaded by Unacademy. If it is valid, hoops are prizes are waiting for you, so don't miss it. Now, before we proceed with the plus subscription features explanation, why don't you all just share the class to all your friends and ask them to join the class as soon as possible? Are you all going to do that? Anshika, Aditya, Jia, Bhumika. Hey, I'm here, Aditya. You don't have to miss me. है ना? ठीक है. Those who are not a part of plus subscription till now, बच्चा लोग, you're missing lot much of features. Let me tell you what all amazing features you will miss if you're not a part of Unacademy platform till now. Now, we all are learning through YouTube, isn't it? And it's an amazing thing that we are learning through YouTube. But, right, once you're a part of Unacademy platform, you're going to get so many amazing things which you are missing from YouTube. First thing, I know that many students would love to have that personal mentoring or personal guidance directly from the educators, isn't it? Many of you would love. And this is completely possible once you're a part of Unacademy platform. More than that, top educators of the country who's having a very good experience will be there to teach you very well. Right, because of their immense experience in educational field, they'll be knowing what all examination pattern you should be expecting for the exam, okay? And they'll be telling you what all questions you should be practicing so that you can make the best preparations for all the examination, ace in all the competitive examination you write and finally end up in the colleges you dream about, right? Then study material, practice test, live test series, whatever you need, everything is on your plate. Now, if you go for 12-month subscription, it should cost you 1,250 per month, mera bachcha log. And if you need 10% of discount, you all know the code, right? It's AMB10, so don't forget it. Now, if you go for Iconic, you'll be getting all the features of Plus, plus some extra features such as personal mentor, right? Live doubt-solving classes, weekly reports. And for 12 months, it should cost you 2,333 per month and extra 10% of discount with the code of AMB10. Right? Okay, mega offer is going on मेरा बच्चा लोग. If you go for 12 months or more than that subscription, right, 2 months ऐसे मिल जाएगा. And this is only valid for first 500 subscription, so don't miss it. जल्दी से जल्दी जाकर go for it, everyone. Right? Okay. Now, बच्चा लोग बता दे. Are you all ready to start this new lesson? अच्छा वाला, awesome वाला, बढ़िया वाला. Are you all ready for that? जल्दी बता, जल्दी बता. How many of you are ready for the session to get started? अरे Ameer, no worries Ameer. You can call me like your brother. Mithilesh, we are ready. Jia, Pardeep. My first live session, being looking forward to it. Hi, welcome to the class, Vishaka. So happy to have you here and so many students like you. ठीक है? Okay, let's get started. Oscillation, right? What it is. But chalo, in this entire class 11, we have learned about so many motions, right? Let's talk about circular motion, right? Let's talk about projectile motion. Let's talk about linear motion. Let's talk about rotatory motion. We have learned about bahut sara motions, right? In 11th standard. And let's say in this particular chapter, we are going to be learning a new kind of motion, ek naya motion. That is what we are going to learn in this particular chapter, which is oscillatory motion. And obviously this oscillatory motion is a very huge topic. Okay, we'll not be learning all the kinds of oscillatory motion. We will be confined, okay, we'll be only doing a very small part of oscillation, which we call it as SHM. From today onwards, you'll be listening to this word every day, 5 times at least, which we call it as simple harmonic motion. The simplest form of oscillation is a simple harmonic motion, and that is only what we are learning. But ठीक है, even though it is the simplest form of oscillation, you will find it a bit difficult. Okay, reason क्या है? अरे the reason is all these concepts what we learn from this particular topic है ना बच्चों लोग, it's new to you, so it will take some time for you. And obviously whenever we learn new things, right, in order to get adapted to it, in order to understand all the concept behind it, it will take some time. So it will take time. So don't lose your hope. Keep on studying. ठीक है. Now, for explaining and making you understand oscillatory motion, we have to start from the first, okay, nannu munnu basic wala motion, which is periodic motion. ठीक है, we'll start from periodic motion, then we will slowly climb towards the oscillatory motion. Fine, देख ले everybody. I think white color is best than red color, right? One best example for periodic motion. Periodic motion. But chalo, you all can write the heading. अरे periodic motion क्या होता है? Okay, if someone asks you, define periodic motion. Can I define? Okay, then I'll go for the explanation, right? Motion which repeats, I think I should be writing in a bigger letter, right? Which repeats in regular intervals of time, we call it as periodic motion. I know that my handwriting is not so good, but I hope you all can read it. है ना? Which repeats in regular intervals of time, that is called as periodic motion. Most of you might have got the idea. ठीक है, but anyway, I'll explain in detail ये क्या होता है. I'll give you an example also. देख ले, this is something we all know. We have our sun right in the middle. ठीक है, we have so many planets revolving around. Let's take our प्यारा वाला Earth. Okay, and we know that Earth is revolving in circular orbit like this. ऐसे, we know that it is elliptical motion, right? Let's make an approximation that the Earth is revolving around the sun in circular orbit. ठीक है, let's say it starts from this position, which I mark it as A. क्या हो जाएगा? From this position A, it will start ऐसे ऐसे, it will keep on going ऐसे, okay, keep on going, and it will be coming back to the same position A. Right? It starts from A, it will be making a motion and come back to the same point A, and after that, isn't the same motion getting repeated? देख ले, after this particular point, the Earth is going to be continuing with the circular motion, or it will be repeating the same circular motion, right? These kind of motion, okay, which will be getting repeated after some interval of time, we call it as periodic motion. ठीक है, tell me what is the period after which the Earth will be repeating the same motion? अरे 1 year. Okay, 1 year is the time taken for the Earth to make one complete revolution around the sun. So after 1 year, it starts from A, come back to the point A, and after 1 year, it will be making or it will be repeating the same motion. समझ में आ गया? What is called as a periodic motion? देख ले, the definition itself will tell you. Motion which repeats in regular intervals of time, वो होता है periodic motion. ठीक है? No doubts in this. I hope everybody got it. है ना? नन्नू मुन्नू कॉन्सेप्ट था, बता दे. Isn't it? Yes, Mithilesh. Okay, Mithilesh is with full of thumbs up. हाँ सर, बिल्कुल समझ में आ गया. हाँ, 1 year. Everyone is agreeing with me, very. Yes, 1 year 365 or 366 days. Hi, new here. Welcome to the class, Bhumika, Miara, Clearu, everybody. Clear, right, Bhumika, Miara, Meru. Okay, awesome. So periodic motion, though, yeah. I know that you are not waiting for periodic motion, right? Because this chapter is about oscillation or simple harmonic motion. So you'll be like, sir, explain oscillation. Explain oscillation. Dekhle. Now it's time for explaining oscillatory motion. Okay, also called as vibration. But usually there is a slight difference between this oscillatory motion, vibratory motion. Okay, motion is the same, but the term will be used in different situation. I'll be explaining obviously. Okay, when will we use the word of oscillatory motion and when are we going to use the word of vibration? Okay, dekh le. Now let's say here we have a simple pendulum, right? And this simple pendulum is hanging from this roof of a building, let's say, which is from the point of A, and on from this vertical position, right, I am just holding it upward, or I am raising to some height here, making some angle of theta with the vertical, right? Which means at time 0, this is the position of our bob of simple pendulum. ठीक है? Do you know what I'm going to do? हाँ, मैं तो छोड़ देगा. So once I leave this bob, tell me what happens. From this position, वो तो नीचे आ जाएगा, नीचे आ जाएगा, नीचे आ जाएगा. It will come to this point. Will it be stopping here? No, it will be going to the other end. ऐसे. It will be stopping after making some motion, and it will be coming back to the central position, going back to the right extreme. मतलब it will keep on moving ऐसे, isn't it? Right? And how can we define this motion? देख ले, about this center position, the particle is moving towards left, right, or we call it as to and fro motion हो रहा है ना? Zoom, isn't it? This to and fro motion about a mean position, we call it as oscillatory motion. What is it? How can you explain or define oscillatory motion मेरे बच्चा लोग? To and fro motion. To and fro मतलब डूम चुक, ठीक है, वो वाला motion. To and fro motion about an equilibrium position. We call it as what? Oscillatory motion. ठीक है? Now ये तो समझ में आ गया ना? जुम चुक उतना ही है. You don't have to think that अरे बाप रे or many things are going to come related to oscillatory motion. Nothing like that. ये जुम ये है oscillatory motion. But now I'm going to ask you a question. Is oscillatory motion, I am writing in short form, is oscillatory motion a periodic motion? Is oscillatory motion a periodic motion? Tell me. बता दे. Let me see who's going to answer me that in the chat box. Jia, Bhumika, Shreya, Meru, कौन? हाँ, doubt भी पूछ लिया आप. Yes or no? Nikhil says yes. और कोई नहीं? Nobody knows. There is no one so brilliant here in this class to answer this question. Yes, Bhumika, Aman says yes. Mansi is like no. Bhumika, yes. Okay, so some are like yes, sir. Some are like no, sir. ठीक है. अरे, what is the simple definition of periodic motion? A motion which repeats after regular intervals of time, isn't it? Let us take the case of the motion of simple pendulum. देख ले, it starts from here. Okay, now I'm using red color. You all can see. It starts from this right extreme, है ना? It comes. It will reach at this equilibrium position. What is equilibrium position? I'll explain. ठीक है? It will reach at this equilibrium position. It will go to the left extreme. ठीक है? ऐसे आ गया. From left extreme, it will be coming back to the equilibrium position again, matlab to the center position, and it will be going back to the right extreme. Okay, started from position A, came back to the same position, and after it come back to the same position, isn't the same motion going to get repeated? Isn't it going to be making the motion from this A towards the mean position? Yes, it is going to be making the same repeated motion, right, in this case of oscillatory motion also after regular intervals of time. So all the oscillatory motions are periodic motion. Kyun? It repeats its motion after regular intervals of time. देख ले, आप ही देख ले. अरे ये हमारा बॉब है, ठीक है. It starts from here, jum chick. अरे after reaching here, it is going to be making the same motion from jum chick. देख ले, jum chick. Isn't the same jum chick going on throughout? है ना? है या नहीं? Yes. So all oscillatory motions are periodic motion. Yes. All oscillatory motions are periodic motion. ठीक है. Opposite, reverse, is it correct? Reverse matlab, are all periodic motions oscillatory motion? Answer is no. One best example is hamara Earth around the Sun. This is obviously a periodic motion, like we have already discussed. Is it oscillatory motion? For oscillatory motion, right, it should be making aise jum around the Sun. Jum. Is it making aise jum? Is the Earth moving like this? Is it making to and fro motion? Bilkul bhi nahi. ठीक है, as Earth is not making this jum motion, right, this motion is only periodic motion. ठीक है, it is only periodic, not oscillatory, which means all periodic motions are not oscillatory motion. समझ में आ गया? Because this is one periodic motion which is not oscillatory, so we can write all periodic motions are not oscillatory. लेकिन vice versa तो correct है ना? All oscillatory motions are periodic motion. ये तो बहुत important है, ठीक है भाई. चलो, okay, don't forget to write it down or note it down. बहुत important है. Fine. Okay. लिख लिया ना बच्चा लोग? सब लिख लिया ना? What is periodic motion, oscillatory motion क्या है? Okay, what are the relationship between this oscillatory and periodic motion? सब एல்லாம் clear. Okay, फिर तो बढ़िया. Okay. Now nobody asked me, sir, ये equilibrium position क्या होता है? ठीक है? और in some other oscillatory motion, how can we find out an equilibrium position? What is the definition of an equilibrium position during the time of its oscillation? Okay, देख ले, I'm going to explain to you. Now, when it is making jum motion, मतलब oscillatory motion, it comes to this special point. Can you see? At this position, okay, when the bob is vertical. Do you know what is the speciality of that point when the bob is perfectly vertical in its vertical position? It's very simple. Okay, there is a simple connection that acts on forces here. I'll explain. Let's say this bob is having a mass of m. So there will be a downward force of mg, right? And there is an upward force of tension here on the string. Is that bob accelerating in the vertical direction? Is it moving? No, it is tied to the string. As long as the string is not breaking, isn't it? That bob is not moving in the vertical direction. उसका मतलब क्या है? उसका मतलब क्या है? The upward tension force is equal to the downward mg force, which is weight of the body. Which means if someone asks you what is the net force acting on this particular bob in this vertical position, net force will be equal to upward T minus mg. Why minus? Array opposite direction. What is T minus mg? Array T and mg are equal in this vertical position, 0. At this vertical position, the net force acting on the body which is undergoing oscillatory, क्या है? 0 है. So now I hope everybody can define what is an equilibrium position. How can you define? Very simple. If the particle is making as an oscillatory motion, whenever it comes to a point where the net force is 0, that point is, वो होता है equilibrium point. Okay, equilibrium position is a point where F net equal to 0. I hope you all can see na. इतना तो नन्नू मुन्नू नहीं हैंड राइटिंग आई सपोज. ओके, फ्रॉम नेक्स्ट ऑनवर्ड्स आई विल राइट बड़ा, स्पेस तो कम है इसीलिए पॉइंट फॉर नेट फोर्स 0 होता है. ठीक है, दैट इज हमारा क्या है, इक्विलिब्रियम पॉइंट. ओके, सो नाउ आई होप you all know how to find out the equilibrium point of any oscillatory motion given to you. Can't you do that? Vagisha, Jia, Shreya, Pardeep, Mithilesh. समझ में आ गया ना? अरे if anybody asks you, अरे ये equilibrium point क्या था? You'll be like, अरे equilibrium point बहुत easy है. If the net force acting at the point is 0, वो होता है equilibrium point during oscillation. Welcome Sai, welcome to the class, right? Okay. Now, ये भी हो गया, equilibrium point भी समझ में आ गया. What is an oscillatory motion वो तो समझ में आ गया, right? And अभी तक sir, we didn't understand the difference between this oscillatory motion and vibratory motion or vibration, right? अरे both corresponds to this to and fro motion only. ऐसे को we define, okay? Both the words correspond this to this to and fro motion. But usually oscillatory motion, the word oscillatory motion is used when, right, this number of oscillation is made less in number. मतलब in the case of a bob itself, just take the example, right? In the case of bob, right, it will in 1 second, right, it will be hardly making 2 oscillations or 1 oscillations or 3 oscillations, right? Matlab the number of oscillations made is, I say, is very less. In those cases we usually call the word as oscillatory, right? Less number of oscillations. Okay, we usually call the word as oscillatory motion. तो vibration कब होता है? अरे very simple, right? When there is more number of oscillation, बहुत सारा oscillation होता है. तो example चाहिए देख ले. You all know tuning fork है ना, ऐसे. Okay, now on one of its legs है ना, on one of its arm, I'm just giving a huge hit with a hammer. Tell me what happens. अरे this particular arm will be moving to the right extreme ऐसे. Okay, it will be vibrating the right extreme and will also be vibrating the left extreme. But in this case, बहुत सारा oscillation it makes है ना, बहुत सारा jum, it will be so fast. In these kind of cases, when there is a large number of oscillations made, we usually call it by the name of vibratory motion. आ गया समझ? It is one and the same. Okay, there is no harm if you use or replace the word vibratory with oscillatory motion or oscillatory with vibratory motion. But usually, whenever we make a statement, oscillation is used in that case when number of oscillation is less. When it is so large in number, we use the word of vibratory motion. Clear? Bhumika, Rahul, Nikhil, Shreya. Jum 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 oscillatory, jum 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 vibratory. Okay, got it? Okay, ये भी लिख ले everyone. Sir, 2x2 Bhumika in class. So this is that special occasion where both the Bhumikas are there in the class. Awesome. Okay, what is one oscillation? I'll explain it. ठीक है, don't worry. When we start dealing with time period and frequency, everything, don't worry बच्चा लोग. We are not going to leave anything. ठीक है, what is one oscillation, right? How much is 100 oscillation? What is time period, frequency, everything. ठीक है, everything we are going to discuss in detail. Okay, ये बता दे, उसका आंसर बता दे. नन्नू क्वेश्चन है. Right? I just don't want to keep on giving you so much lectures. So I thought, okay, Nannu Munnu question I'll add in between. So Nannu Munnu question aa gaya. Just give me the answer for this. Okay, one of the Bhumika Pandey has given me the option B here. Mithilesh A. Then Vishaka says periodic. Or kya? Jia A, Nitishri periodic, Jasmine periodic, omega b. Okay, and it's very simple. Read the question. A particle moves in a circular path with a uniform speed. ऐसे circular motion, just like a planet is revolving around the sun. What kind of motion it was? Periodic. So if a particle is making circular motion, वो होता है periodic. Why it is not oscillatory? अरे the particle which is moving in circular path is not making that to and fro motion, that jum 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 motion. Only if it makes jum 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 motion, we can call it as oscillatory. Right? Here jum 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 motion नहीं हो रहा है for a particle which undergoes circular motion. So it's obviously periodic motion. Fine. Okay. Good. Awesome. Fine. Good. Now, it's time to discuss about so many things. Okay. I know that many of you are asking, sir, how much is one oscillation? How can we understand that एक oscillation तो हो गया? Second thing, what is time period? What is its relation with frequency? Frequency क्या होता है? What is angular frequency? Omega, बहुत सारा questions है, I know that. Okay, now we'll deal with one by one. Ready है ना आप सब लोग? हाँ, Junjun motion, Junjun effect, right? Okay, let's get started here. Right, everyone. When can we call, right, one oscillation is completed when a particle is undergoing oscillatory motion? अरे बहुत simple है, देख ले. We'll take the same example of, okay, simple pendulum. I'm rising this bob to some height from its vertical position. I'm rising to some height which makes an angle of theta, right? देख ले. Initially, matlab when the time is 0, the particle was at the point A. Tell me what happens. If you leave this bob, it will be so happy to move from this particular position towards the equilibrium position. It will be reaching here. Is it going to stop here? No. By the time the bob reaches at this equilibrium position, it will be having so much of velocity. Na? Zoom, it is coming from a height. So with that velocity, it will be continuing its motion towards the left hand side and either पहुंचेगा, let's say to some point B or a point on the left extreme. From there, once it stops, it will be changing its direction of motion. It will start coming towards the equilibrium position, and from the equilibrium position, it will be coming back to the same point A. देख ले, it starts from A, go to equilibrium, then move towards B, from B towards equilibrium and come back to the same position A. And after A, after reaching at the same point A, is it not going to repeat the same motion? Yes or no? Yes. So, if it starts from one point and come back to the same point, we will say that, yes, one oscillation is completed. एक oscillation is हो गया. अरे, what is the definition? Definition क्या होता है? अरे, the motion of the body before it gets repeated itself is called as one oscillation. Starts from point A, go to B, come back to the same point A. After that, is it not going to repeat the motion? हाँ, बिल्कुल. So before repeating the same motion, whatever motion the body is making, that complete motion we call it as one oscillation. समझ में आ गया? Starts from go to other point, come back to the same point. वो हो गया one oscillation. ठीक है? You all want the definition, right? लिख ले everybody. One oscillation. One oscillation is defined as motion before it repeats itself. It repeats itself. वो होता है one oscillation. Okay, देख ले कितना नन्नू मुन्नू definition है ना? कितना नन्नू मुन्नू definition हो गया. Okay. Next is time period. क्या होता है? Time period क्या होता है? अरे क्या होता है? Okay, usually we use the symbol of T. What is time period? For completing one oscillation, doesn't it take some time? Yes, and that time required for one complete oscillation, we call it as time period. That is starting from the point A, going to B and coming back to the same point A. Won't it take some time? It will take some time, and whatever the time taken, that time we call it as time period. Okay, समझ में आ गया ना? अरे लिख ले, अरे definition भी लिख ले. Now I hope there is no confusion in that. Time required. Everybody, you can Read it along with me and give the definition. Time required for one complete oscillation. क्या आता है? Oscillation. That is called as time period. Okay. So one oscillation समझ में आ गया, time period भी समझ में आ गया. Okay. So I'll give you 10 seconds before I move to the next page. Any doubts you have? This is the 10 second where you can tell me in the chat box. Sumat, Nikhil, Jia, Mansi, Ayush, Mithilesh. Very good, Mithilesh. Awesome, awesome. Yes, time required for one complete oscillation. Yes, sir. Mera got it. Meru, Mansi. Okay. कितना छोटू and simple है और क्या? Okay, we'll make this entire big chapter so छोटू, okay, and make it easy for every one of you to learn. I think you also want the same manner, है ना? We'll do that. So time period तो हो गया, one oscillation हो गया, okay. Next thing, frequency. Everyone write the heading. Frequency क्या आता है? Frequency का मतलब ये है कि number of oscillations made in 1 second. Okay, in 1 second कितना oscillation, how many oscillation is being made, वो होता है frequency. Okay, what is it called as? That is called as frequency. आ गया समझ? Okay. Now, अरे let's say from here to here, right, we call it as one oscillation. So if you take the time of 1 second, in that 1 second कितना झुम motion हो सकता है, right, that is simply called as frequency. No doubt in that, right? I think I don't need to explain much on that. But what you need to know is the relationship between, right, frequency and time period. Many of you might be knowing frequency is equal to 1 by time period. But I think every one of you or whoever knows this formula might have by hearted this, है ना? F is equal to 1 by t. Without knowing ये relation कैसे हो गया? How does a frequency is equal to 1 by time period? You all want to know, right? अरे India wants to know, nation wants to know, right? So let's understand how frequency is equal to 1 by time period. How this equation popped up? देख ले. I'll say that what is time period? Time for एक oscillation. Time for one oscillation is equal to time period, right? Okay. Frequency का मतलब ये है कि number of oscillations made in 1 second. How to find out the relationship between? I'll give you one example. ठीक है? देख ले. I'll write it at the extreme bottom. Time for ripening. Don't have to write it. I'm just giving you an example. ठीक है? Time for ripening one mango. एक मैंगो राइप करने के लिए कितना टाइम लगेगा? Let me say that 0.1 day. In 0.1 days, right, one mango will be ripened. Question, right? How many mangoes will ripen 1 day? How will you find out? 1 day or 1 day divided by time required for what? Ripening of one mango, which is 0.1. 1 by 0.1 वो होता है 10, right? मतलब in 1 day 10 mangoes will be ripened, no doubt in that, right? Okay. Similarly, time required for एक oscillation is time period. Okay. So how can you find out the number of oscillations made in 1 second? You will find out how many time periods are there in 1 second, or 1 by time period. Same like 1 day by 0.1. Here we have finding out how many time periods are there in 1 second. So 1 by time period will give us what? We'll get to know how many time periods are there in 1 second, because each time period corresponds to one oscillation. So if we can find out how many time periods are there in 1 second, that will correspond to number of oscillations in 1 second, which will be equal to frequency. Simple. Okay, now you don't have to by heart frequency, why it is 1 by time period. You all can. ठीक है? अरे बिल्कुल बिल्कुल स्नेहा. Okay. कौन परेशान कर रहा है? Block him, block him, block him. कौन? अरे you all can block any person or any chat you don't find good in the chat box. ठीक है? whichever chat you don't like, click on that person's name, option आ जाएगा block कर ले तो वो block will be gone from your chat box. Fine. So one oscillation is from A to B, नहीं, A to B and B to A. A to B and B to A makes one oscillation. Okay. हो गया ना? Frequency, time period, one oscillation, one last thing. Okay. एक last thing है, what is called as omega. Omega, we usually call it by the name of angular frequency. होता क्या है? सर बता दें, angular frequency क्या है? Omega, we usually write it with the symbol of omega, right? And it is usually called as angular frequency or angular velocity also. Sometimes we call it by the name of angular velocity also, omega. Those who have learned circular motion with me might be knowing omega क्या है? Angular velocity. अरे usual velocity क्या है? Displacement by time. So angular velocity, which is the term coming using or during circular motion, is angular velocity is equal to, instead of linear displacement by time, इधर होता है हाँ angular displacement theta by time. Omega, angular velocity, is equal to angular displacement theta divided by time. What is the definition you can give for this? Array theta by time means angle made in 1 second. In 1 second, if a particle is undergoing oscillatory motion, how much angle it covers, right? 1 second पे कितना angle cover करेगा? That is called as angular frequency. क्या है angular frequency once again, right? How much angle an oscillating body covers in 1 second. That is called as angular frequency or angular velocity. ठीक है. Now you all want to know the relationship omega holds with frequency. Okay, omega and frequency. The simple relationship I will tell you first. Then we will go for the derivation. Omega का formula ये है कि 2 pi f. Omega is equal to 2 pi f. Okay, now I'll help you. Right? ये कैसे? Okay, why there holds a relation of omega equal to 2 pi f. ठीक है, देख ले. F क्या था? Let me see how many of you do remember. Number of oscillations made in 1 second. Okay, 1 second पे कितना oscillation हो गया? That is called as frequency. Tell me. Okay, in one oscillation, how much angle it covers? Okay, एक oscillation हो गया. How much angle it covers? It covers 2 pi. मतलब 360 degree. एक oscillation पे. Let's say 2 oscillations. So that will be equal to 2 times 2 pi. 3 oscillation, 3 times 3 pi. Okay, f number of oscillation it makes, the angle it covers is equal to f times 2 pi. In 1 second, कितना oscillation कर रहा है वो? F oscillation. So if it makes f oscillations, the angle covered in 1 second कितना होता है? 2 pi into f. So 2 pi into f क्या आता है? 2 pi into f is actually the angle covered in what? In 1 second पे. ठीक है. अरे angle covered in 1 second क्या होता है? Omega. Simply we got the relationship. On the left hand side we have 2 pi f, right hand side पे omega है, वो तो equal है. We just proved that. Omega 2 pi f, 2 pi f omega, omega 2 pi f. हो गई बात. Right down. जल्दी 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 जल्दी. अरे just to make you happy स्नेह मैं ऐसे बोल दिया. If you are first time तो बिल्कुल बढ़िया. Everyone, just write down. Jaldi. Yes, Jia, Matalesh, Sumit. हो गया बात. What are you teaching, sir? How to be a very good person. That's what I'm teaching right now, Jay Lakshmi. Arey, we have started new chapter na oscillation. We are dealing with the concept from those topic. Written Vishaka. Noted. Note किया. Okay. आजकल making a person happy is also a very गलत thing. देख ले. Someone asked me, sir, do you remember? मैं तो सोच लिया, do I remember? मैं तो बिल्कुल नहीं. But I didn't want to make that person bad है ना. मैं ऐसे ही बोल दिया, हाँ बिल्कुल. Okay, आपका मैं ज़रूर. I do remember. फिर भी मेरा ऊपर. Right? देख ले, everyone is over me, sir. आप तो गलत कर दिया. अरे telling छोटू lies to make a person happy, not बड़ा like ऐसे छोटू lies good है ना? What do you all say? Is it good or bad? अच्छा बात है, बुरा बात है, अच्छा बात है, बुरा बात है, अच्छा नहीं है ना? हाँ वरुण, अरे हिंदी में समझा रहे, पहले मुझे हिंदी समझा दो, मुझे आई एम नॉट सो गुड विद द लैंग्वेज ऑफ हिंदी, इसीलिए ओके तो इधर तक समझ में आ गया सबको? नोट किया ना? अरे बिल्कुल awesome awesome. इधर तक समझ गया है तो most of the concepts are clear to you. Now tell me, I know that I didn't talk about the actual displacement and oscillatory motion, but for doing this question you all have the right idea. नोट किया ना? अरे जल्दी जल्दी जल्दी. माही 25 Feb को भाई की शादी. अरे if all people from here right now at least 70 people are there live, so if all these people come and everyone who is watching this chat come है ना, per plate I think it costs 200-300 rupees. कितना जाएगा आपका? Okay, anyway, I have the answers like A, Nitishra, Mithilesh, then Sumit बोल रहा है, Bhumika बोल रहा है, Attitude Girl बोल रहा है, Ruksha, Riya, Mansi, Bhumika. Everyone is like sir A. अरे बिल्कुल सही है. Displacement तो 0 है. Question क्या है? The displacement of a particle in oscillatory motion in one time period, एक time period पे, if we let the particle to make oscillatory motion, what is the displacement? अरे क्या होता है? नन्नू question है. Let's say it starts from here. It go to equilibrium, go to the left extreme end, ठीक है, वापस आ जाएगा, and it will be coming back to the initial position from where it started. Then we will say one oscillation तो हो गया. Starting from first position and ending up at the second final position, and the net displacement कितना है? Initial and final position same है. Displacement कितना होता है? 0 है, right? है ना? Just like Shreya Kumari is back, है ना? The particle is also back at the same position. तो 0 होता है. Simple. Okay. Fine. Now, displacement. I don't know how many of you took the topic till now seriously. Those who are not taking this topic seriously, there is no point in staying back with this chapter other than have some good time in the chat box. Okay, having good time in the chat box, you can all do that. But if you want to learn this chapter well, and if you want to understand this concept of displacement for the next 15 minutes, right, पूरा का पूरा ध्यान इधर होना चाहिए. अरे मेरे चेहरे पे नहीं, right, whatever I say and whatever I write on the screen. How many of you can promise me that? कर सकता है? कर सकता है या नहीं कर सकता है? सर मैंने ये चैप्टर पढ़ा है लूसीफर. अरे बाप रे, बढ़िया बात है. In their own world है ना, let's get them busy. कोई बात नहीं. Those who want to learn, I hope you all are here and your ears are just waiting for my words है ना, and your eyes are just looking into whatever I'm writing on the screen. वही say even if it is 10 students in the class, okay, I'm happy. Okay, ठीक है. देख ले what is called as a displacement. बच्चा लो, as an example for simple oscillatory motion, let's say, because we haven't started with simple harmonic motion, which we are going to soon start. We only have started with oscillatory motion, and the best example that we were taking till now वो था. Okay, Bob ऐसे ऐसे, okay, हिल रहा है. Okay, that oscillatory motions example that we were considering till now was Samara simple pendulum. Now let us take a new example, because it is with that new example it will be more comfortable for me to explain and for you to understand. देख ले everyone. Topic displacement. नया example, and this new example you will be seeing for explaining all the aspects of oscillatory motion from here onwards. देख ले everyone, listen here. I have a string, string nahi spring, and at the end of the spring I am connecting it to a body of mass. Matlab, I haven't extended the spring. Spring is in its natural length of L, right? So tell me, when it is in this particular position, is the mass going to move anywhere? No, it will be stationary position, right? And let me ask you, at this particular point, what will be the net force acting on the body in the horizontal direction? Bata de. Just have a look at it. Spring is not tight, so spring won't be giving any force, and we cannot see any external force acting on this mass. So obviously net force in the horizontal direction 0 hai. Okay, net force 0 hai, what do we call this position as? We call this as equilibrium position of this oscillatory motion. ये होता है equilibrium position of this oscillatory motion. ठीक है? Fine. Now, do you know what I'm going to do? Alright, just like what every humans do. Whenever you find any other person sitting so calm, peaceful and quiet, we like to go and disturb that peaceful mind. है ना? Right? We all love doing that. Same thing I'm also going to do. देख ले, this mass and the spring was आराम से उधर बैठ रहा था. So what will I do? मैं तो खींचेगा. I'll start pulling this mass, let's say towards right. So I'm gonna pull that mass ऐसे, okay, ऐसे, 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 ऐसे to some position. Now this is the new position of this particular block, which means with respect to the equilibrium position, matlab from here, I have drawn a line, the new position of the mass is here. Yes or no? Yes. So the position of the particle with respect to the equilibrium position, वो होता है displacement. देख ले, from the equilibrium position, the current position of the mass is at a distance of x, and this path, right? This position from the equilibrium position, उसका नाम है displacement. आ गया समझ? Usually we use the term as x here, and this is called as displacement. Okay, initial part of displacement आ गया. From where will you measure displacement of a particle which is undergoing zoom 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 motion? From the equilibrium motion. Fine, right? Okay, I'll write the definition. The position of a particle with respect to WRT का मतलब है कि with respect to equilibrium position. ठीक है, वो होता है displacement, which is usually written or expressed with the symbol of x. ठीक है, let's see. From this particular position, right, I'm going to leave the mass. अरे, after extending the spring है ना, I'm going to leave the mass from that particular position. हो क्या हो जाएगा? What will happen? अरे, when the spring is extended, a force is produced, right? If the spring is extended, the force on the spring will be to bring back the mass to the equilibrium position. मतलब spring will be pulling this mass towards left, right, with the spring force. The equation of spring force will come to it later, right? The spring will be trying to bring back the mass towards the equilibrium position. It will be constantly pulling the mass towards the equilibrium position, right? As a result of that, if we remove all the external forces from it, the mass will start moving towards the equilibrium position, है ना? देख ले, इधर से आ जाएगा, it will start moving ऐसे 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 ऐसे. This force will be there throughout. It reaches the equilibrium position. Once it reaches equilibrium position, force to 0 हो जाएगा. We know that. But as there was continuous force acting on the body, right, the particle continuously got accelerated, and by the time it reaches here, the particle will be having a huge velocity. And do you know what will happen to it, the particle with that velocity? Is it going to stop here? Bilkul. it will start continuing its motion towards left. Okay, it will start moving until it makes a displacement towards left. Okay, and until it stops after some point of time. It keeps on moving towards left. And why the velocity has to decrease and become zero after some point of time? Arey, dekh le, once a particle starts moving towards left, okay, you are compressing the spring. Spring to chota ho raha hai. So it will obviously be resisting. We know that, right? Right? There will be a spring restoring force is being produced towards the right direction. Okay, once the spring is compressed. So obviously, once the force is towards the right direction, acceleration is also towards the right direction, which is opposite to the direction of velocity. Block was moving towards the left direction. Okay, acceleration is in the opposite direction. Magnitude of speed or velocity will decrease continuously. After it some time becomes zero. And after that, what happens? Yes, this mass will be moving towards equilibrium position. It will continue as jum motion. Okay. Now, during this jum motion, the mass at this particular point, dekh le, I am marking it with some, which letter can we use? Which letter? A, B, C. Okay, I'll use the letter C here. Okay, this is the point on the right side where the particle is at maximum displacement. Do you all agree with me? At the point C, we can see that the mass M is at maximum displacement. Yes or no? Maximum away from the equilibrium position. Yes or no at point C? That maximum displacement, X max, do you know what we call it? At a maximum displacement, we call it as amplitude. Hota kya hai? Amplitude. That maximum displacement is called as amplitude. So starting from here, at this end position, we call it as amplitude. And if it moves value of A towards right, obviously, it will be making the same motion towards left also. Matlab, the maximum displacement towards left is also A. ठीक है? ठीक है? आ गया समझ? What is amplitude? How to measure displacement? ये सब सही है? ठीक है, जल्दी बोलते हैं. सुमित, मानसी, attitude boy. Okay, so is the handwriting chotu ho gaya? Okay, I'll try to increase my handwriting. Okay, it's the size of the letters. Okay. Now, I said something here which might have made confuse you. I don't know how many of you are confused with this fact, right? Dekh le, I told you it makes a maximum displacement of A towards right. It makes a maximum displacement of A towards left. So, while expressing the displacement, how can we know that whether the particle is at the right side of equilibrium motion or at the left side of equilibrium motion? Kaise? How can we understand? Very simple. If the particle is on the right hand side, okay, if it is at the right hand side, we mark the displacement as positive, either to positive, and if the particle is at the left hand side, it is marked with negative. Matlab here it is plus amplitude and either to minus amplitude. आ गया समझ? आ गया? देख ले, it is not necessary, it has to be amplitude always. देख ले, when the mass is being left from the right extreme, it will be moving towards equilibrium position. Let's say, वो तो इधर आ गया, इधर, बीच में. It will be at some position from the equilibrium position, right? So this displacement x, we mark it as plus x. Similarly, if it is moving towards left, ऐसे, the particle is here. Let's say the magnitude is same, but how can we express this displacement? Is it a plus x? No, as it is on the left hand side, ये हो जाएगा minus x. So towards right plus, towards left minus. Towards right plus, towards left minus. Learn everything from now onwards. Three things we have learned. Displacement क्या होता है? Everyone try to figure out what is displacement. Okay, the position of the particle with respect to equilibrium. Fine? Okay. Then we have learned amplitude क्या आता है? During oscillatory motion, right, what is the maximum displacement a particle make from equilibrium? वो होता है amplitude. Second thing. And how can we express whether the particle is at right side or at left side of equilibrium? By using plus sign to say that it is on the right hand side, and by negative sign to say that it is on the left hand side. All good? Fine? बोल दो ना जरा, जल्दी बोल दे. हाँ, maximum displacement, equilibrium position. You should be knowing only all these things. All is well, all is well, all is well. Okay, good, right? So displacement, you all understood, right? What is displacement? Now what we need? And हमको क्या चाहिए? We know that a particle starting from here, it keeps on changing its position. मतलब displacement keeps on changing with respect to time. So we need a formula to find out the displacement of any particle which is undergoing oscillation at any point of time. What is our mission? What is our next mission मेरा अच्छा लोग जल्दी बोल दे. अरे हमारा mission alpha A or alpha A, whatever you want to call it, mission Bharat. What is our next mission? To make an equation for displacement. Equation for displacement. Are you all ready? Are you all ready for that? Everybody है ना? Mission alpha है, mission SHM. Okay, you all have your own names for missions, right? ठीक है. Okay, fine. Going on. Equation for displacement, and here it goes. देख ले. Everybody listen here. We'll take the same example of our spring mass system. Fine. ये हमारा wall है. Let's say that this is the floor, and we have this spring mass system here. So obviously this is our equilibrium position, like we already have discussed. Now, do you know what I'm going to do? क्या करेगा? We already know. If we find something sleeping or resting, we will go and trouble them. So from this equilibrium position, I am going to extend this particular spring or stretch this particular spring to a maximum displacement of A. I'm going to stretch this, right? I'm going to stretch this spring to a maximum displacement of A towards right. Okay, and I'm observing this particular motion, right? Matlab at t equal to 0, at time 0, we have this particular mass here, and now I'm going to observe the motion of this particular mass once you leave it. Okay, ready? And everyone, eyes open. Let's see what is happening to the motion of this mass once you leave it. Tell me क्या हो जाएगा? Once you leave this will start moving towards the equilibrium position. Right? Okay, it will start moving towards the equilibrium position. Once you start moving towards the equilibrium position, क्या हो जाएगा? अरे displacement will keep on decreasing because it is coming close and close and close and close and close, and after some time it will be reaching what? The equilibrium position. मतलब displacement तो zero हो जाएगा इधर. After that, it is going to continue its motion towards left, है ना? मतलब it will be making negative displacement. After some time it stops. After making a displacement of minus A, then it will be continuing its motion from minus A towards equilibrium position. मतलब this motion will be continuing. Isn't this what happens? Yes. Now, for every time, if we mark the displacement on displacement time graph, let's see what is the shape is going to be. मतलब I have a motion here, right? I make this spring mass system to oscillate starting from this particular position, right extreme end, say. For each time interval, I am finding out its displacement. I am marking it here. Tell me कैसे हो जाएगा? At time 0, at this particular point, where is the particle? The particle is at its maximum displacement here, है ना? इधर तो हो जाएगा, ठीक है? बहुत बढ़िया सर, बहुत बढ़िया. उसके बाद I leave it, right? From this position it will be leaving, it will be moving towards equilibrium position. as it move towards equilibrium. As it is coming close to the equilibrium, displacement to come ho raha hai, and once it reaches the equilibrium position here, this will be the displacement 0. The graph also has, after some time, it has reached the displacement of 0. Fine. After this, what happens? From the equilibrium position, it will be moving towards negative displacement position. Negative pe. ऐसे जाएगा, until it makes the maximum displacement in the negative direction. सही है? Right? And after that क्या हो जाएगा? अरे it will be repeating its motion from minus A, it will be moving towards equilibrium position. मतलब again it will be displacement 0, and from equilibrium it will be moving to the right extreme. ऐसे. Right? Starting from the right extreme, it has came to the right extreme itself. मतलब here to here makes one complete oscillation. Right? It makes one complete oscillation, and the graph was looking like this. Once the displacement and time was plotted for this body undergoing oscillatory motion. ये तो सही है. Do you find this graph similar to any other graph you have learned before? देख ले अच्छे से. देख ले everyone. Look into the graph and tell me, do you find this graph so familiar? Have you seen this graph before? बोल दे. Anybody? किसी ने देखा है क्या? श्रेया, Attitude Boy, मिथिलेश, परक्षित, मानसी, म्यारा, प्रीति, नितश्री. अरे कॉस का ग्राफ है. I don't know how many of you do remember. If we are plotting on the x-axis angle theta and on the y-axis cos theta, if we plot, the graph is exactly looking like this. Right? Where the maximum value of cos theta कितना है? Maximum value of cos theta ये होता है. How much? 1. Yes or no? And here we had the equation as y equal to 1 into cos theta. Yes or no? ठीक है ना? Now if we use this same concept, of cos graph for making an equation for displacement for oscillatory motion, it will be very simple. Okay, here on the y-axis, what do we have? देख ले, here y-axis पे, here we have displacement x. So I'm going to plot it here. Instead of on the y-axis, here we have displacement x. ठीक है. Here we have 1, which was the maximum value of cos. Here what do we have instead of that? Is it 1 here? This is amplitude A. So instead of 1 here, I'll be putting A here. Fine. Cos of theta, I'm going to just rearrange Q, because you know that theta by time is equal to omega. ये तो सही है ना? सबको पता है. Angular velocity we have discussed some moments before. Theta by time, angle per unit time is omega. So theta का value होता है omega into t. So for theta, I'm going to replace as a cos instead of theta. I'm going to write it as omega t. Why? Because here on the y-axis, on the x-axis, it is not theta. Here we have time, and x displacement is a function of time, so it has to be a function of time itself, not a function of theta. So we just made a chotu change in this theta by writing it as, replacing theta as omega t. Say, this is the formula for displacement. क्या है? This is the formula for displacement of a particle undergoing oscillatory motion, starting from where? From where we have started our observation, from the right extreme end. This is very much important. If the particle starts from right extreme end, displacement for oscillatory motion होता है a cos omega t. Very important. Note it down. अभी के अभी, तुरंत से तुरंत. अरे साइन के आई विल एक्सप्लेन. अभी तो कॉस का हो गया. कॉस के बारे में जस्ट लर्न अबाउट कॉस के बारे में. फाइन. When the time comes about sine, we learn about sine. Perfect. और क्या? Awesome. Okay, now we learn about what? Sine का graph. When the sine graph is gonna come. ठीक है ना, नोटेड. What does A stands for? विशाखा में तो बिल्कुल कितने बार बोल दिए, A for amplitude, maximum displacement. अब याद आ गया? याद तो आ गया है क्या मेरे बच्चे लोग? याद आ गया ना? ठीक है, तो हम चलेंगे चलते चलते. देख ले. Everybody listen here. Everybody listen. Let's see. Right? Is the equation for displacement is going to change? Is this function of cos going to change if we change the point of observation? मतलब in the above case or in the case that we have discussed, है ना? Initially particle was at right extreme. Based on that, we made the formula of x as a cos omega t. Now we are using a different point of observation. Okay? In that case, let's see, is there any change in the equation for displacement going to be or not? ठीक है. देख ले, सेम हमारा एग्जाम्पल स्प्रिंग मास सिस्टम. ठीक है, स्प्रिंग तो इधर है, मास तो इधर है. ओके, एंड यू नो व्हाट आई एम गोइंग टू डू? आई एम गोइंग टू कंप्रेस द स्प्रिंग टू द लेफ्ट हैंड साइड. Okay, and I'm going to leave it from that like left extreme end. Okay, from the left extreme end आ जाएगा. And when I started observation, the mass was here. मतलब the mass was here exactly at the equilibrium position when I started observing. ठीक है ना? Okay, now देख ले. For the same observation, I'm going to plot displacement time graph. Okay, देख ले, at time 0, this is at equilibrium position, x equal to 0. मतलब point तो इधर है. I hope you all can see. Okay, ठीक है ना? Okay, tell me what will happen to this mass after this time t equal to 0. It will start moving towards right, है ना? It will start moving towards right का मतलब it will move away from equilibrium. If it moves away from equilibrium, x value keeps on increasing, right? In the graph, starting from 0, x increases till it reaches the maximum value of displacement, right? Okay, x increases till it reaches the maximum value of displacement. We call it as amplitude. देख ले ये value, this x we call it as amplitude. उसके बाद after reaching at the right extreme, it will start coming towards the mean position. मतलब displacement तो कम हो जाएगा ऐसे. मतलब you know, right, how the graph is going to be. It will be looking like a sine graph. Alright, this graph exactly looks like a sine graph. So in this case, if we start our observation from equilibrium position, say if we start observation, right, the formula for displacement क्या होता है? अरे this sine graph, so it will be a sine omega t. Yes or no? Yes or a no? Yes or a no? Isn't it? So according to the graph we plotted, in this case, when we started our observation from the mean position, displacement का formula होता है a sin omega t. Isn't it? Yes or no? आ रहा है, concept आ रहा है दिमाग पे, है ना? ठीक है. I'm gonna make छोटू changes here. ठीक है. अरे इधर तक everybody noted आना. मिथिलेश, कार्तिकेय, प्रीति. If you need some time, I'll give you 15 seconds. Go for it, everyone. Yes? Yes, Lakshman. Note किया सबने? अरे वाह, बिल्कुल, awesome. ठीक, we'll proceed. Fine, Mithilesh, Mera, Jia, Lakshman, okay, everyone here in this class, Nitishri, Diksha, okay, हम continue करें. Now, by using concepts of trigonometry, I'm going to make some changes to this equation. देख ले, a sin omega t, I'm going to write it as a 90 minus omega t, क्योंकि 90 minus omega t तो sin omega t है. अरे cos 90 minus omega t sin omega t only. It doesn't make any difference, right? Okay, देख ले, a cos minus of omega t minus pi by 2. I took negative sign outside. So instead of pi by 2 minus omega t, I can write it as minus omega t minus pi by 2 with negative sign outside. ठीक है. Tell me. Cos minus theta क्या आता है? Cos of minus theta is cos theta only. So cos of minus of omega t minus pi by 2 क्या आता है? A cos omega t minus pi by 2. Can you see that? Can you see that? Matlab, when it was from the right extreme end, the formula was A cos omega t. When we have changed the point of observation in this particular case, you actually don't have to change the sign, change the function from cos to sine. Right? What do you need to do? From the already existing omega t, add or subtract another angle so that we get the equation, right, for the particle undergoing oscillatory motion with what? With any point of observation. देख ले, when we have changed the point of observation, उसके साथ we just have changed the value of angle inside this cos so that it can match up to the current point of observation. समझ में आ गया? What I wanted to say was, you don't have to change from cos to sine. That function doesn't need to be changed, right? You just need to change the value of angle inside this cos value. आ गया समझ? आ गया समझ? And this angle we add, can you see this angle? Here in this case it is pi by 2. In different point of observation वो तो different होता है, right? This extra angle we added so that it can match up to the current point of observation. ये होता है initial phase. ये क्या है? ये angle क्या होता है? Initial phase होता है. ये तो initial phase. Okay, why initial phase? That extra angle we add in order to match up the initial position of the particle. देख ले, initially it is at the equilibrium position, right? In order to match up that point of observation, we'll be adding some angle here, right? That is called as initial phase. And in total, मतलब whatever is inside this cos or sine, this total angle को we call it as phase. मतलब total omega t minus pi by 2 का नाम है phase. That extra angle of pi by 2, pi by 6, whatever we add, we call it as initial phase. आ गया ना? Initial phase क्या होता है? Initial phase क्या होता है? Clear, everyone? So in general, बता दे, what will be the general formula for displacement? That will be equal to A cos omega t plus some angle, let's call it as phi, so that we can match up the initial point of observation, which we call it as, ये phi का नाम है initial phase. अरे obviously yes, which reference point from which reference point the particle is making the observation will be given, because without the point of reference point we cannot determine the equation of displacement. It is very important, right? Initial reference point or the initial point of observation, that is very much mandatory, because only after that we can fix the value of phi. Okay, we'll do some questions, Lisha, and then we'll wind up the class. 15-20 minutes more. Okay, so this is your time to just keep on giving a love. Okay, so you all can show some love towards your bhaiya by clicking on the like button. Okay, fine, hai na? Diksha, Myara, Sumit. Question se pehle. Okay, I know that you'll be 80% clear. Right? I need to make the concept of this initial phase 100% clear to every one of you. Okay, so just listen to me when I explain this particular example. You will understand about this equation of displacement and initial point of observation, है ना? पूरा 100% clear हो जाएगा, है ना? Just like a clear sky you have, this will be clear after listening to this example. देख, everyone listen. Everyone. If anybody is hungry and if anybody wants to leave only after listening to this particular example. ठीक है? That will be my advice to you, because this is very important. सो ये तो हमारा x इक्वल टू 0 पॉइंट मतलब इक्विलिब्रियम सबको पता है. ओके, एंड दिस विल बी making SHM motion, oscillatory motion, jum 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 motion, and let's say that during its jum 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 motion, when I started to observe, obviously keep on making motion, jum 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 jum, है ना? When I started to observe, मतलब when the time equal to 0, the particle was at a displacement of x equal to a by 2, let's say. कहाँ है वो? At a displacement of x equal to a by 2. So at this particular position, I started observing this. Now our question is how to write an equation of displacement for this particle when we start the observation from this point. Okay, this is not the amplitude, this is not the right extreme. From here also the particle will be continuing its motion until it reaches an x equal to a. So the particle is in between motion, neither at its equilibrium position nor at the right extreme at beach पे. And we start our observation from this particular position, ठीक है, and we want to make an equation for this motion. कैसे करेंगे? We can write the basic general equation for representing any simple sorry, let's not say the word simple harmonic. Okay, any oscillatory motion. Formula क्या है? X equal to a cos omega t plus phi. This equation will only complete once we define the value of phi for this particular motion. How? We know one simple idea here. देख ले, at t equal to 0, at t equal to 0, right, when we started observation, x का value कितना था? x का value तो a by 2 है. अरे just substitute these two information in the above equation, get the value of phi. तो हो गया हमारा इक्वेशन. x का वैल्यू a by 2, a by 2 इक्वल टू a cos ओमेगा t प्लस phi. अरे भूल गया, 2 सब्स्टिट्यूट t इक्वल टू 0. अरे ओमेगा इंटू t का वैल्यू 0 होता है, राइट? सो ओमेगा इंटू 0 इज 0, 0 प्लस phi इज phi. ओके, सो इनसाइड cos ओमेगा t कैंसिल हो जाएगा, वी ओनली हैव phi. So a cancel on the left hand side, it is 1 by 2, right hand side पे cos phi, because omega t cancel हो जाएगा, time तो 0 है. अरे cos phi if it is equal to half, tell me what is the value of phi? Pi by 6. मतलब अरे pi by 6 नहीं, अरे बिल्कुल, I'm sorry, pi by 3, which is 60 degree, because cos 60 is equal to half, right? So we got, by using the above information, according to our point of observation, phi का value pi by 3 होता है. So we got our specific formula for displacement of this particular particle कितना? अरे x equal to a cos omega t plus phi value we got it as pi by 3. And this is the exact specific equation for oscillation for the above particle which is undergoing oscillation. आ गया या नहीं आ गया? And how many of you are 100% clear? Just raise your hands. Raise your hands. बोल दे हाँ सर, बिल्कुल समझ में आ गया, अच्छे से समझ में आ गया. How many of you can confidently say this? जल्दी बताओ, जल्दी बताओ. किस किस लोगों को बता सकता है? क्लियर आ गया समझ? 99.99%. अरे 0.01 कहाँ गया मिथिलेश? Shoot the questions. अरे वाह, someone is using very good English here. Shoot the question. अरे वाह. और नॉट 1 हो गया, ज्यादा हो गया ना थोड़ा मेरा, थोड़ा एक कम तो कर ले. This is right point है ना, देख ले आदित्य. This point is right only. According to what I have drawn, ये पोजीशन इज राइट ऑफ इक्विलिब्रियम. आप भी बता, ये तो राइट है, ये लेफ्ट है? अकॉर्डिंग टू मी इधर इक्विलिब्रियम, इधर तो राइट ही है. दैट्स व्हाट आई वाज थॉट. एक पर्सन जेम्स के लिए जोड़ दे. ठीक है, आई डोंट नो व्हाट इज द रिलेशन ऑफ दैट विद आवर व्हाट वी आर लर्निंग एनीवे. लगता है आई थिंक यू मेंट सम जोक्स, है ना जी यार? ठीक है, थोड़ा हंसेगा, हंसने पे कोई कुछ नहीं हो जाएगा. 4.01 मेरे पास है ठीक है, फास्ट रख ले आप. एक्स्ट्रा मार्क्स फॉर गुड स्टूडेंट ऑलवेज, ठीक है. सो सेल्फ डिक्लेयर्ड गुड स्टूडेंट है ना मेरा आप, बढ़िया बात है तो ठीक है, थोड़ा क्वेश्चंस करेगा है ना, मचा देगा, एंजॉय करेगा थोड़ा, कर ले. फर्स्ट क्वेश्चन आ गया, पहला क्वेश्चन आ गया. Okay, maximum velocity, just cut it for the time being because we haven't learned है ना concept of maximum velocity. मैं कट कर रहा हूँ, बता दे. एक्स्ट्रा मार्क्स फॉर गुड हैंड राइटिंग. अरे गुड मुझे तो ऑब्वियसली I'll be getting negative marks for हैंड राइटिंग. वो तो सर गिव एग्जैक्टली 1 minute. अरे इसको एग्जैक्टली कुछ भी नहीं चाहिए. Nobody needs 1 minute for this. If you are asking 1 minute का मतलब you are not listening. Last 10 more seconds you all have. Fine. Okay. I couldn't find. Okay. One person have given me amplitude का value. Bhumika, very good. 10. देख ले. Forget this SHM because I haven't explained it. Just think that an oscillatory motion we have. What is an SHM? I'll explain later. ठीक है? Okay. So is represented by the equation x is equal to, an oscillatory motion, let's say, is represented by an equation of x is equal to 10 sine pi t plus pi by 6. This is the equation to represent our oscillatory motion. If you want to get any idea out of this equation, just write the general equation to represent any oscillatory motion. क्या होता है? X is equal to a sine omega t plus phi. Now you can easily say which terms corresponds to what, right? देख ले. The coefficient of sine or cos or whatever it is, it will be corresponding to what? So amplitude का value मिल गया 10. Now going into the function, okay, देख ले, whatever is the coefficient of time that will be corresponding to omega. So time का coefficient क्या है? pi. So omega will be equal to pi. And phi का value क्या आता है? Pi by 6. Right? Okay. अरे question is not to find omega here, time period. कैसे? ओमेगा इज इक्वल टू सर 2 पाई एफ, है ना. 2 पाई एफ इज इक्वल टू 1 बाई टाइम पीरियड. सो ओमेगा इन टर्म्स ऑफ टाइम पीरियड भी मिल गया. ओमेगा इक्वल टू 2 पाई बाई टाइम पीरियड. सो टाइम पीरियड विल बी इक्वल टू 2 पाई बाई ओमेगा, दैट इज 2 पाई बाई ओमेगा का वैल्यू पाई है. पाई पाई कैंसिल हो जाएगा, टाइम पीरियड मिल गया 2 सेकेंड. डन. आ गया. एम्पलीट्यूड का वैल्यू भी मिल गया, टाइम पीरियड का वैल्यू भी मिल गया, सब का वैल्यू मिल गया, मजा भी आ गया. खुश कर ले बच्चों लोग. यस और नो, नो और यस. क्लियर? मिथिलेश, लक्ष्मण, भूमिका, मियारा, दीक्षा. ओके. कैन वी जंप टू द नेक्स्ट वन? अगला क्वेश्चन. जूम. ओके. आई होप यू ऑल हैव नोटेड डाउन. अगला क्वेश्चन तो आ गया. एवरीवन, बच्चा लोग, एवरीवन जल्दी से कर ले. You all know, choose equation wisely because everything is told here in the great manner. It's always A, M, B, 10. बोल दो ना जरा. Am I invisible or doing this on purpose? कौन? आप तो invisible नहीं है. Ashok, hi. Anurag, hello. Uttar, anyone? Can anyone give me the answer here? No. किसी के पास नहीं. अरे देख ले. I'll explain. Okay. अच्छे से सुन ले. A particle executes simple harmonic motion with a time period. Time period का value दे दिया. It's 4 seconds. Right. Okay. Find the time taken by the particle to go directly from its mean position. मतलब we are starting our observation from mean position. And if it starts from mean position, what's the formula for displacement? We already know. We already have derived A sin omega t. Now we don't have to spend time by finding the value of phi, because A cos omega t plus phi was our general formula. Obviously, once you find the value of phi, you will get it as minus pi by 2, and finally you can turn it to cos of 90 minus omega t is equal to sin omega t pi. You will come across. We already have learned this and derived this. Great. Okay. Now find the time taken. Matlab question is to find the value of t. Okay, and time taken for what? For the particle to move from the mean position to half of its amplitude. Matlab, if it moves to half the amplitude, what is the displacement? A by 2. From the mean, if it travels a distance of a by 2, obviously displacement x का value a by 2 होता है ना? ठीक है, substitute कर ले इधर, x का value a by 2 is equal to a sin omega t. बिल्कुल सही है, a cancel. Now we get half is equal to sin of. अरे, is there any way to find omega? Because omega equal to 2 pi by time period. Just now we have used, that is 2 pi by time period is 4 given. ठीक है, so pi by 2 हो गया omega का value. कोई शक नहीं. So substitute कर ले, omega is equal to pi by 2 into t. Tell me, for what angle of sine we will get half? For that angle of sine which is equal to 30 degree or pi by 6, because sine of 30 degree has to be 1 by 2. So we have to assume that a pi by 2 t is equal to 30 degree or pi by 6. Fine. Okay. Pi cancel करेगा, 2 in 6 3 times. So time is equal to 1 by 3. No. Isn't it? Yes, pi by 6. Very good मेरा. चलो बिल्कुल सही है आप सब. हो गया everyone? Done. Okay. Now I'll give you okay, ठीक है. इधर तक बस आज के लिए डन. बहुत भूख लग रहा है मुझे. What do you all say? आप लोगों की बहुत भूख लग रहा है ना? मुझे तो बहुत लग रहा है. So I'm gonna run to some shop outside here. Okay. When to use sine, when to use cos. Okay. General formula for any simple harmonic motion, I'll just give you a simple right. General formula is always, general formula क्या होता है? A cos omega t plus phi. Okay. General formula. अरे थोड़ी ना space दे दो. Okay, I'll write. General formula for displacement is equal to A cos omega t plus phi. This can be used for expressing any kind of displacement, any point of observation. Fine. But we already have the equation directly for displacement if it starts from right extreme and either say we already have derived the formula A cos omega t. Matlab here in this case we don't have to take the pain of finding out the value of phi here. If it is given in the equation that it starts from right extreme end, we can directly use a formula of x equal to A cos omega t. Similarly, if we start our observation from the mean position, either you can put the value of t equal to 0, x equal to 0 in our general equation, get the value of phi, or use our direct formula which we already have derived where x equal to A sin omega t. So from the mean position, formula for displacement is A sin omega t. Cool? Everyone, bacha log, sab cool, is everything okay? And have you all understood everything? अरे सब समझ में आ गया तो किसको वेट कर रहा है, किसको इंतजार कर रहा है? Move your cursor, just show some love towards your भैया है ना? Just click on the like button, do let me know that you have enjoyed the class and everything is super clear. Okay? Yes, Rahul, Dhirendra, Aditya, Bhumika, Rukshar, Riya, Sumit, Mithilesh. Okay, yes. Fine, awesome, good. Okay, from simple harmonic motion, how an oscillatory motion will be considered as a simple harmonic motion, we'll be discussing in tomorrow's class. Wait till then. Fine, we'll be discussing so many bouts aa raha hai, theek hai. So yes, now if you also want some scholarship while you join your college time, Unacademy Prodigy exam is there. Next exam is on Feb 13, 12 to 1 p.m. Don't forget to enroll. You can enroll it for free with the code of AMB10. Fine. And here we have the schedule at what all time and at what all dates it happens. And if you grab first time MacBook Air, 2 to 3 Apple iPhone, 4 to 5 iPad. Fine. And CBSE class 11th ka batches that is happening, you all can be a part of it. You can see amazing teachers are waiting for you. Okay? And special class timetable, I'll be sharing it with you wherever chalo. And you all know awesome features of Unacademy Plus special classes, right? Live chats, question tab, live polls and quizzes, leaderboards. Everything is just going to make your studies so awesome. So don't forget. This is your time to share some love towards your bhaiya, move your cursor, click on the like button, do share it with your friends, subscribe to the channel so that you'll get all the notifications, and dhanyavad. Lucifer, Mithilesh, Sumit, Rahul, okay, Nancy, Sab, Jia, Diksha, Sab, okay, Rahul, Mansi, everyone, dhanyavad. Have a very good awesome night. Don't forget to study for a bit more till we meet next